Friends, last lecture was actually based on the some of the Ncert exercise questions. Now let's discuss about the some of the rest of the questions left in the Haloakane and Haloarene exercise, and we are starting from the question number 10.41 sorry, question number 14 from the exercise. The first question you can see, the first question is actually Finkelstein reaction. You can go through the Ncert book, just open your Ncert book and go through the questions. First question is given here. The chlorobutane with sodium iodide, dry acetone, there must be Finkelstein. There will be exchange of the halogens atom that will give you the major product. Next question is tertiary bromide. The tertiary bromide is here. KOH ethanol must be going for the beta elimination reaction whenever sodium hydroxide or potassium hydroxide in the presence of ethanol must be there beta elimination reaction. Halogen and hydrogen eliminated from the compounds. Next question is secondary bromo. So there must be SN1 reaction and sodium hydroxide in the water will give you a two different product, inversion product and retention product. Next question is Caesian aqueous ethanol. There must be a bromoethane is there. So SN2 reaction will be product. SN2 reaction will be product. Next question is very interesting, fifth one, because there is phenoxide, sodium phenoxide and chloroethane. Sodium phenoxide and chloroethane. So whenever there is sodium phenoxide, because of the bulky reason, because of the steric hindrance reason, the elimination generally predominate over the substitution, but there will be both the product form. You can go through the SN2 mechanism for substitution and beta elimination reaction with the same time. Both product can be formed in this reaction. Next one is actually associated to thionyl sulfonyl chloride. So this primary alcohol going for the SN2 mechanism to produce chloropropane. Next one is HBr peroxide must be anti-marconi carb addition reaction. Double bond will break down and bromine at the first position of the carbon. And next one is tertiary alkene. There is HBr simply. So bromine must be go with the tertiary carbon with a Marconi carb addition. This is all about the 14th question. I am making here hint. You can complete all the questions in your copy. Next question 16th and 15th based on the mechanism. One of the question is mechanism. Normal butyl bromide. The primary butyl bromide is actually always showing, generally showing the SN1 mechanism. You can go through the SN1 mechanism for there. And question number 16 based on the reactivity towards SN2. Reactivity towards SN2 based on the two things. If there are the different of haloalkane with the same alkyl group, you can go through the best leaving group like iodine, then followed by bromine, chlorine and fluorine. If the different alkyl group are there, you can go through the steric hindrance property. The more steric hindrance must be less reactive towards SN2, less steric hindrance going for the good SN2 mechanism. So you can see which one of them is a good SN2 mechanism. So in the good SN2 mechanism, you can choose your own. I'm just making hint here only. Hydrolysis by aqueous KOH. There is given actually benzyl chloride, I think, and dibenzyl. Dibenzyl. No. Diphenyl. 1,1-diphenyl chloromethane. So this is actually whenever there is a great proportion of the double bond in conjugation, there is a great ability to show the resonance. The second one will be more easily hydrolyzed by aqueous NaOH or KOH because of the resonatically stabilized intermediate, that is carbocation. Para-dichlorobenzene has higher melting point than solubility, higher melting point and solubility than those of ortho and meta isomer, because para-dichlorobenzene is having a symmetrical structure, that must be going for the fit in the very easily in the lattice. How the following conversions can be carried out? The conversions actually based on the practice of the different reactions given. Actually students, the conversions. So you must be first practice all the reactions belonging to this chapter one by one, and all these reactions will make you a good in the conversion. So first conversion is propene to propanol. Propene to propanol. Whenever there is unsymmetrical carbon is there and functional group attached at the first position, there must be use of the anti-Marconi of HBr addition. So first go through anti-Marconi of HBr addition first step, then going for substitution SN2 mechanism, and that is aqueous KOH ethanol to butadiene. That is also the question in the conversion. Question number 11, the first question already discussed in the last lecture. 1 bromopropane to 2 bromopropane students. First going for the elimination reaction, aqueous ethanolic KOH, and then going for the simple Marconi of HBr addition. Toluene to benzyl alcohol, going for the chlorination in the presence of sunlight will give you a benzyl chloride. Then going for the KOH and NaOH. All these questions belongs to the NCERT. You have to be first discuss the NCERT question, go through the different NCERT exercise and all the reactions given in the book. Practice all the question, then you can be answer the more easily, more appropriately. Okay. Benzene to 4-bromo nitrobenzene. Whenever there is 4-nitro, you must be first step going for the ortho-para directing group, that is bromine, because nitro group is meta directing. So if we going for the first step nitration, there will be 3-bromo, means meta bromo nitrobenzene, because nitro is a meta directing. But first step you going for the bromination, bromine in the presence of AlBr3 or FeBr3, then go for the 1-bromobenzene. Then last step will be, the second step will be nitration in the presence of sulfuric acid, must be produce the desired product. Benzyl alcohol to 2-phenyl ethanoic acid. This is the one of the simplest reaction but not given in our syllabus. So you can go through the first benzyl alcohol, going for the actually just chlorine. Chlorine can substitute that OH group. Just take SOCl2 or you can take a PCl5 also. That will substitute that OH group, will give a benzyl chloride. Then going for the potassium cyanide will give you a cyanide at the position of chlorine, and on complete hydrolysis of cyanide there will be complete hydrolysis of cyanide always produce, you can see complete hydrolysis of cyanide always produce carboxylic acid. So this reaction actually the last step you are not knowing about. So 2-phenyl ethanoic acid can be done with the help of last step this reaction. Next, ethanol to propane nitrile. This is the one of the simplest reaction, because first we are going for the SN2 mechanism, SOCl2, then propane nitrile. Very easily you can take a potassium cyanide. Aniline to chlorobenzene, Sandmeyer reaction, and before Sandmeyer you can go through the diazonium salt preparation, nitrous acid in the presence 0.5 degrees Celsius, chlorobenzene, cuprous chloride, HCl presence, that is called Sandmeyer reaction. 2-chlorobutane to 3,4-dimethyl-hexane, simple Lorentz reaction, one-step reaction. 2-methyl-1-propane to 2-chloro-2-methyl-propane. I think that should be a simple addition reaction of HCl, Marconi-Cow. Ethyl chloride to propanoic acid. Again, ethyl chloride, first substitute that chlorine group by cyanide group, and then going for the hydrolysis of the cyanide will give you a carboxylic acid. But1 into N-butyl iodide must be there, must be a pink listing in the last. So first going for the simple addition reaction of HBr, anti-Marconi-Cow in the presence of peroxide, then go through the Finkelstein reaction that will substitute bromine by iodine, halogen exchange reaction. 2-chloropropane to 1-propanol, 2-chloro to 1-propanol I think. So there must be a first going for the 2-chloropropane to 1-propanol. So go for the elimination reaction I think. First step elimination reaction will give you propene, then HBr anti-Marconi-Cow in the presence of peroxide will give you 1-chloropropane, Then go for the aqueous KOH, will substitute that chlorine at the position first. Isopropyl alcohol to iodoform, it is the one of the simplest reaction but not given in the haloalkane haloarene chapter. This is from the next ketone chapter. So isopropyl alcohol, the 2-chloropropane, you can see 2-chloropropane, just take iodine and sodium hydroxide will give you a CHI3 iodoform. Chlorobenzene to pyranitrophenol. So chlorobenzene to pyranitrophenol, go for the simple nitration. First step nitration, paranitrochlorobenzene will be there. Then take a 368 Kelvin temperature, sodium hydroxide with some pressure to atmosphere will produce a pyranitrophenol. 2 bromopropane to 1 bromopropane, shifting of bromine from the position to second to the first must be HBr addition in the presence of antimaroconica, and before addition there must be elimination. So first go for the elimination reaction, propene will be there, then HBr antimaroconica. Chloroethane to butane, simple Woods reaction. Benzene to diphenyl, Fittig reaction. Tertiary butyl bromide to isobutyl bromide, again there must be shifting of the bromine from the tertiary to secondary, I think. So there must be an antimaroconica HBr addition in the last. First go for the elimination. Aniline to phenyl isocyanide, this is also not given in our syllabus in the first chapter. So you can take aniline, CS benzene with NH2 group, then alcoholic chloroform, that will substitute the add that benzene with the NC called isocyanide group. These are the 20 conversions given in your question number 19. Go for all these questions and write all these questions on your copy, and if there is any problem, try to ask me. Thank you. Okay.